Hello viewers, hope you are all well. Today I am going to discuss three broad-based product design approaches which are design for the supply chain, design for logistics and design for X. You can also call it design for excellence or everything. So let's start with the first approach, that is design for supply chain. I would like to start my discussion by showing you this basic model of supply chain so that my viewers can easily associate and grasp the concept of design for supply chain design. We all know that in a supply chain, we have a supplier who furnishes us raw material, then there is a manufacturer who manufactures the product, and there is a distributor, retailer, and end customer or a shopper. Products travel from upstream to downstream channel and goes through many different phases or processes to reach an end customer. Design for the supply chain design is an approach which is used to come up with a product design which ensures the smooth flow of your product from upstream to downstream channel. In this approach, product is designed in such a way that it is suitable for the whole supply chain and it doesn't cause any problem or issues in the whole chain. For example, let's say you introduced a toothpaste in a triangular shaped packaging, but you didn't take into consideration that it will be difficult for a retailer to stack it on the shelf. In this case, there is a high probability that your product will fail since it will cause an issue or a problem at the retailer's end. So, ensuring that your product is compatible with the supply chain issue is just one aspect of design for supply chain design approach. The other aspect of design for supply chain is that your product should meet other supply chain goals of faster inventory turnover, low inventory costs, reduced inventory transit time, and quicker time to market as well. I would like to close my discussion on this design by saying that design for supply chain is the process of optimizing the fit between supply chain capabilities and product designs. It creates product configuration that address infrastructure limitations and use supply chain capabilities as they evolve throughout the life of the product. Let's move on to the next design, that is design for logistics. You can also call it DFL. DFL utilizes product design to minimize transportation and storage costs. Logistics specialists are involved early in the product design process and determine how to package, store, and transport the finished goods conveniently and cost effectively. You will find multiple examples of this particular design in everyday life. For example, stacking chairs inside one another. You can easily differentiate that the chairs on the left side are not designed for the ease of logistics and storage purpose, whereas the chairs on the right side can be easily stacked inside one another and transported. They will also occupy very less space in a warehouse or anywhere you are storing them. Now look at these garbage pails. One on the left is the traditional old design of garbage pail with no wheels attached, whereas the one on the right has wheels which can be used for easy transportation. Now look at this crate of bottles. This is another good example of conveniently transporting beverages. Now take a look at this picture of square watermelons, which are specifically grown in this particular shape for ease of transportation and storage. I hope you know the whole process. Farmers put them in a die made of iron or steel when they reach a particular size, so they acquire the shape of square box. Anyway, how they are grown is not our point of discussion. I would like to highlight here that sometimes design for logistics fails as well. There are many farmers who have faced many issues with this design of watermelon. Many farmers report that watermelons rotted during the transportation or storage due to aeration issues. Since they were stacked and jam-packed too tightly, watermelons in the middle or at the bottom hardly received any air to keep them fresh. As a result, they started rotting very fast. Similar case happened with one of the cheese manufacturers as well, who was storing his square-shaped blocks of cheese in a freezer. He realized that blocks on the top and side layer are fine, but the cheese blocks which are in the middle are turning stale. Again, this is because of the lack of cooling. Cool air, which is supposed to keep the cheese cold and fresh, couldn't reach the cheese blocks which are in the middle of the square. You will find many other examples like IKEA furniture, etc., to associate this design with common things in your household. Now let's discuss some benefits of DFL design. Design for logistics help you minimize transportation cost. It also helps you minimize storage cost. You have just seen the example of those stacked up chairs. You can easily transport them, you can easily store them. Other benefits of this design are that master carton can be used for restocking. Retailers can also sell products directly from the pallet. So this was all about the benefits. Now let's move and discuss some trade-offs. The biggest trade-off of this particular design is that it is not feasible or practical for the goods which are slow moving and are not required in large quantities. Other issue with in this approach is cube out versus way out balance. Now what is cube out and what is way out? Let's say you are manufacturing an alarm clock. You have a specific carton box in which you can place 12 boxes of alarm clocks for transportation. There is no more space to add any more boxes of alarm clock. This means that the carton is out of space. This is cube out. Okay. Now let's say you are manufacturer of marble showpieces. Since marble showpieces are quite heavy as compared to the alarm clocks, you might be able to place only 4 or 5 of them. Otherwise your carton will start tearing apart. Although your carton has a lot of space, but you couldn't fill it up since it has weight out. Weighing out is utilizing the capacity of a package or container by filling up with products that could hit its weight limit. Now let's discuss design for X, which is also known as design for excellence or design for everything. If you are an algebra or a PMP student, you might be wondering that design for X means design for anything. If this is so, you are absolutely wrong. In PMP or in algebra, X is considered anything, whereas in CSCP or in supply chain, it is considered everything. X is considered everything, and they have a valid justification to call it everything. Design for X is generally used by engineers in order to design a particular aspect of a product. The X in design is a variable. The X can be substituted for things such as assembly, cost, safety, quality, or deployment. For example, you can do design for cost, which would bear cost in mind to ensure that your product is profitable when produced. But when it comes to supply chain, design for X means developing a product by inculcating or including multiple designs in a product or a service to meet a company's strategic goal. For example, IKEA's furniture can be considered a good example of design for logistics and modular design both. Why? Because it can be easily transported in parts and then assembled at the destination, which is an aspect of design for logistics. Secondly, some parts can be used to produce multiple configurations of a product, which is an aspect of a modular design. That was end of today's discussion. I hope you understood all the 3 design approaches in this video. I'll be making another video for another 3 approaches and so on. If you find value in this video, please consider subscribing to my channel and pressing the bell icon. Thank you.